Again, Art Warren, Director of Sales at Lytyx, and I'm going to introduce our presenter this morning, who is Paul Meisty. Paul is the founder and president of Lytyx, holds a PhD in statistics, and has over 20 years of experience doing customer analytics and optimization, advanced analytics, and marketing optimization. So with that, I'll turn it over to Paul.
Thank you, Art. Good morning, or in some cases, good afternoon to everyone. First, Art, a quick check that you can hear me. Okay.
I can hear you fine, Paul.
Okay. So we're happy to have all of you join us today. What I want to do is jump right into it. Let me give you a brief background on our company and our solutions. In particular, I want to spend some time showing you how our optimization solution, LityxIQ, works and how problems are structured with it. But as quickly as possible, though, I do want to jump into live demonstrations. I'm sure you all will be looking forward to that, but do want to make sure that you have some background in the inner workings of the tool first. As Art said, we'll leave some time at the end for Q&A, and please send your questions through the GoToMeeting window. So with that said, for those of you who haven't seen us before, let me introduce you to Lytyx and provide some context and background on what we do. At our core, we're a data and analytics solutions firm with a focus on advanced analytics areas, so things like predictive modeling and marketing optimization. We have worked with a pretty diverse set of clients over the years, diverse in terms of size and industry and business needs. And let me now introduce briefly our cloud-based platform for analytics. We call it LityxIQ. It's a fully cloud-based hosted platform currently comprised of 4 solutions, as you see here. So we call them Data Manager, InsightIQ, PredictIQ, and OptimizeIQ. They're fully integrated into a consistent platform and consistent user experience. One key differentiator, which we hope you'll see today, is that the platform is focused really very much on the business user. So complex predictive modeling and optimization models are defined using business language, not programming. So let me quickly walk you through the 4 solutions within LityxIQ, and then we'll jump into a more detailed discussion of optimization, just to give you a little bit of the background on how this all fits together. So the data manager is where data comes into the platform for analysis, so users can manage multiple complex data sources, doing things like joining multiple data sets, cleaning data, aggregating, filtering, adding new fields, and so on. InsightIQ is our solution for drilling deeper into the data to find relationships that may be interesting or useful for advanced analytics, or for just simply showing basic business reports and dashboards, so users can interactively design and create charts and then drag and drop them into dashboards or analytic galleries. PredictIQ is our automated predictive modeling solution. It's focused on building models using business language, but also lets advanced users tweak settings and parameters in advanced algorithms, and easily set up things like large bake-offs. Most of the things that make predictive modeling hard using other tools or classic tools are automatically done for the user in PredictIQ, so things like model validation, performance metric computation, model comparison, version control, and even model implementation. Very easy to do in PredictIQ. And finally, OptimizeIQ, which is the focus of our webinar today. This is our solution for defining, executing, and implementing complex, constrained optimization problems. But as I've already mentioned, it's focused on the business user, so there's no coding or mathematics background required. It's also built to be extremely flexible, so even though we'll talk about marketing certain specific marketing optimization problems today, it's really flexible in that you can really define a wide variety of different kinds of optimization problems that can be solved, and the user really just has to specify a few things about the problem: their dimensions, their metrics, and their constraints. Since the solutions that I've referred to here are integrated, OptimizeIQ can also be linked with results from PredictIQ, so things like model scores or forecasts can easily be used as inputs into OptimizeIQ. So with that background, let's kind of turn the page here and focus a bit on LityxIQ as we go through the rest of the webinar. As mentioned, it can be set up to solve a wide variety of marketing or other business problems, so things like channel optimization, offer optimization, web optimization like online advertising or keyword and search optimization, and we'll see some examples and walk through specifically some examples of that today. Over the next few slides, I want to walk you through how problems are defined in OptimizeIQ through a few simple steps. And of course, we're leading to actually seeing that with a live demonstration, but really makes sense to give some of this background so it's easier to follow the demonstration itself. So it's a good starting point. So first, what we need to do is define the dimensionality of the problem. In other words, across which business dimensions do I need to make optimal decisions, such as a budget allocation? There might be one dimension or two or maybe many dimensions, maybe a dozen dimensions. As an example here, and an example that we'll continue to walk through in the following slides, let's say that we have three business dimensions of interest: products, periods, and customer segments. And at this time, we'll also list out the different levels, as we'll call them, the levels of the possible values for each dimension. So for this example, we have three products, and we've simply labeled them here, products A, B, and C, 2 time periods, and 2 segments. So this definition is important because the optimization that we're going to wind up doing here is performed at the level of the combination of all these dimensions and their levels. And we'll see that a little bit more clearly as we move forward. So then we need to attach some information to these dimensions and their levels. We refer to qualitative information as attributes and quantitative information as data elements. So for example, as you see on the screen there, associated with each combination of product, period, and segment in our little example here might be an attribute that is sales rep that is assigned to that combination of product, period, and segment. So we have 3 sales reps as you look down that list there: Jane, Joe, and Josh. And we also have 2 data elements that we've defined, which might be something like an expected response rate that sales rep is expected to get for that period, product, and segment, and also an average expected average sale size. So you can see those things vary, of course, as we look to different combinations of these 3 dimensions. So notice that we assign values of each attribute and data element to all the possible combinations of their dimensions. In this example, of course, because we had 3 products, 2 periods, and 2 segments, there are 12 such total combinations, and all of those are listed here in this little example. So maybe you can see where we're going here, that our business problem has to do with optimizing sales rep effort across these 3 business dimensions. So let's move forward and let's now define the variable that we want to optimize. Let's call it calls to make. Okay, in other words, we want to determine the optimal number of calls that each sales rep should make into each of these 12 combinations of dimension levels. In other words, where should our sales team focus their effort? It's the optimal way to focus their effort. Of course, to answer that question, it's not answered yet. That's why you see question marks there. That's the thing we want to optimize. We don't know the result of that yet. And of course, to get there, we'll need to have something to drive that decision. And that's what we're about to get to. So at this point, we want to define some summary metrics. Think of these as business metrics, core business summaries that are of interest to us for this particular problem. At the bottom, you can see that we're defining, we have different ways to define and summarize things. So in defining our metrics, we can and should typically use the currently unknown calls to make variable. So for example, a simple metric might be just adding up or totaling the number of calls that our optimal allocation would have us make. All right, so this first one here that's called total calls is just summing up the calls to make. So even though we don't know the answer yet, we're telling our optimization routine that one of the core metrics we care about at the end is the total number of calls that it's recommending we make. Okay, so that's computed simply by summing up the calls to make variable. Moving down, we may define the total number of responses that we'd expect, and that's just computed as the sum of the calls to make variable times the response rate. Similarly, the total sales we would generate by our optimal solution here is computed just by summing up the calls to make and multiplying that by the response rate and further multiplying by the average sale size. Okay, doing that would give us the total sales that result from our optimal decisions about calls to make. So note that we can also define what we call complex metrics. These are just metrics that are based on other metrics. So for example, we can define the overall response rate that we expect from our solution as just the total responses we get, which was defined up above, divided by the total number of calls we make, which was also defined up above. The last step to setting the problem up is to tell LityxIQ what is the business objective. So let's say in this case that we want to maximize overall response rate. Okay, that's going to be the core objective, and that's going to drive the decision about this optimization variable calls to make. Okay, so with this setting, it's going to determine and assign the optimal values of calls to make with the goal of maximizing overall response rate. It's one of many goals that we could define, but for now, let's say that that's our objective, maximizing response rate. But to go along with that, there may be some business constraints that we want the solution to keep in mind or adhere to as it makes those optimal decisions. So for example, and I'll walk through, you see a list of 5 potential constraints here, so I'll kind of walk through some of the ideas behind them. So for example, we might have an overall effort constraint that says we can't make more than 5,000 calls over this 2-month period. Okay, so we will limit the total number of calls we can make to fewer than 5,000. Perhaps we also need to ensure that each of our 3 reps is kept at least somewhat busy. All right, so we need to have at least, let's say, 50 calls assigned to each. All right, so the second constraint here says minimum number of calls for each rep, and that's defined as the total number of calls greater than or equal to 50. And really, it's 3 constraints because it's a constraint that applies separately for each of the reps. We may have a directive from above that says we need to focus most of our upcoming effort on customer segment 1. So we may need to ensure, for example, let's say that at least 55% of all calls are made into segment 1. So we have a third constraint here that's kind of labeled focus on segment 1, and our definition of it is that the percentage of total calls into segment 1 needs to be at least 55. A fourth constraint may be that whatever plan we come up with must generate at least $1,000 in total sales. And finally, a fifth constraint may be for the sake of appropriate resource allocation, we might want to ensure that, let's say, 45% of all calls are made across each of the 2 months. So in other words, we don't want to generate a plan here that puts too much effort in one month or the other. Remember, we had 2 different periods. So that our sales reps aren't twiddling their thumbs in the other month. So distribute at least 45% of the total calls into each of the 2 months. Okay, so once these are defined, and we call all that setup the metadata for the problem. Once that's all defined, we can then execute the problem and start evaluating results. And that's what we're taking a quick look here and moving quickly forward into looking at a live demo. So the first level of results that come back are detailed results. So in other words, what is the optimal number of calls to make for each combination of products, periods, and segments? That's the detailed basis for our optimal effort assignment plan. Okay, and the results might come out looking like you see on the screen there for this particular problem where we had that business objective of maximizing response rate and had those 5 constraints playing a role as well. As interesting, and maybe even more interesting to some folks, are the summary results. All right, so we have the detail, which is how do we, actually put this plan into place. But the summary says, in other words, what do we expect the outcomes to be if we do implement this optimal plan? So we'll get back expected results for all the summary metrics we entered. And for example, this plan here expects to generate about $8,300 in sales based on 112 responses from making a total of just over 1,800 calls. All right, our sales generated per call, it appears, would be $4.61 with this plan. So as long as our cost per call is below that, we'll be profitable. Okay, so with that as some background on how problems are set up and defined in LityxIQ, I'm sure you're anxious to see this work live, so let's jump over to the platform and show how these requirements are translated into the solution. Hopefully along the way here you'll see the ease of setting this up. Okay, so I am going to log in. To our demo platform, and we'll jump right into this sample problem that we just set up in the webinar here as our first little demonstration. Real quickly, I want to show you that we have loaded the data that I just walked through in the PowerPoint into the data manager solution within LityxIQ here. And so that little data set with 12 rows and columns to represent the different dimensions, that sales rep, that response rate, and that average sales size have been imported from an external file. So that data, and this also gets the integration of the components of the platform, that data that we've brought into the data manager, which if we wanted we could further analyze and clean up if it needed to be, is then available to us, and we'll see that in a second here within LityxIQ. So with that quick setup, I'm going to jump right over to LityxIQ and walk you through the setup of this problem, kind of translating that PowerPoint discussion into the solution here. So the first thing I'm going to do in LityxIQ is go to the Manage Metadata link on the left-hand side. And we can start things off by defining the terminology and sort of the overall problem definition as part of the metadata. So here, for example, is where I define that optimization variable, as we referred to it in the PowerPoint, as calls to make. Okay, so that is defined here as part of the terminology of the problem. We saw in the PowerPoint that we set the problem up with 3 dimensions. 3 dimensions are periods, products, and segments. We set those up in LityxIQ here in the dimensions and levels area. As I had mentioned, there's no limit to the number of dimensions, so I can have 1 dimension, 2 dimensions, or 12 dimensions if I want to. At any time, I can add any number of dimensions to the problem, as well as add, delete, or change the names of the dimension levels within each of the dimensions. And by the way, these can be connected up to data sets that we have in the data manager, so I can automate that process in addition to having the opportunity to manually adjust them as well. We saw in the setup to the problem that we did have an attribute that was assigned, that was involved in the problem here, and that the attributes for our problem are defined here in the attributes area. Our single attribute was sales rep, and all we do here to add additional attributes is click the Add Attribute button, give it a name, give it a default value, and that defines a new attribute. Notice at this point we are not connecting to our data set yet, we're just setting the problem up. What are the dimensions, what are the attributes, and what are the data elements? And I've moved into the data elements section here, and we had noted a couple of data elements in the PowerPoint, and you see those defined here. So we have a basic data element called average sale size, as well as one called response rate. Those are set up very simply in LityxIQ by giving it a name, a default value, and then some parameters for how it's displayed on the screen, rounding values, and prefixes for $signs, for example. So very easy to set up data elements. We also have here, notice, a data element that's the result of applying a formula to other data elements. So I have a data element here called $sales per call, which is defined as taking the average sale size times the response rate. So it's sort of an intermediary data element that we need to help us define some of the summary metrics. So Because I can compute that for each combination of the dimensions and their levels, that is defined here as a data element based on other data elements through a formula. Its definition is very similar, except that we provide a formula for how it's computed at the bottom. And finally, something that I didn't allude to in the PowerPoint setup is that there is a special data element that we provide for all problems that's kind of labeled here as a special universe-sized data element. And what I've called it here is the total number of customers. So one limit that you may sort of think in your head is, what is the maximum total number of customers we can call in any one of these combinations of dimensions and their levels? We hadn't put a restriction on that before, but with LityxIQ here, there's an automatic process for doing that with this special universe size data element. And for the sake of this sample little problem here, I've kept things very simple, and I put a default value of 1,000 for this total number of customers. Okay, so in other words, each of these 12 combinations of dimensions and their levels, we're saying that the total number of people that we could contact, the most number of calls we could potentially make in each of those, is 1,000. Of course, in other problems that might be different from one segment and one product and one period to the next, but in this little example, we'll define that as 1,000 for all 12 of those combinations. Okay, so the last part of the setup, as mentioned in the PowerPoint overview, was defining summary metrics and our business objective functions. And so again, those are defined here very much like it appeared as they appeared in the PowerPoint. So for example, my definition of the metric total calls is simply this formula, very easy to create and edit. So again, I give the metric a name as well as some default display properties. And then I can edit its formula through a very simple interface. So I'm saying I want to sum up, and I don't want to use any additional data element in that sum. I just want to include that optimal variable calls to make. Okay, so very simply defining this metric as the sum of that calls to make variable. All right, the total responses, again, as mentioned in the PowerPoint, very similar. That's defined as the sum of calls to make, but in this case I want to multiply that by the data element response rate, so that when those two things are multiplied and then added up across all combinations of dimensions and their levels, it'll give me an overall total number of responders. Okay, and similarly, as mentioned in the PowerPoint, we can define what we call complex metrics. So, for example, overall response rate. When we edit this formula, we click on complex metric, and now we define very simply the numerator for that metric. That's the total responses simple metric that we defined. The denominator is that total number of calls. We can, if we want, add a right-hand side into the formula, but this one's a simple ratio of total responses to total calls. And so in total, like we defined in the PowerPoint, we have 5 summary metrics. Now the key thing is that all the metrics that we define here are now available to us as either objective functions, business objectives that we can use to define the problem, or as the basis for constraints. So with that, let me click on the Define Scenarios link and discuss how that metadata then works its way into a problem that we can now execute and solve. We refer to these as scenarios in LityxIQ, and again, I can have one scenario as I do here, or 2 or 3, or any number of scenarios. Think of them as what-if games. So I may want to play around with different objective functions or different constraints or different data, and see what those results are and compare them to each other before I make my decision about which plan to implement. First key thing before jumping into that to make real clear is how to associate the dimensions, attributes, and data elements that we just defined with information from a data set. And so with each of our LityxIQ libraries, you can associate a data set. So I'm just pointing back to the data set we had briefly looked back at the data manager with those 12 rows and 6 columns in it. And I'm simply in here defining for, again, each dimension, attribute, and data element, which variable in that data set it goes along with, or to associate it with. Okay, so what we've called periods as a dimension here in LityxIQ is associated with the periods variable in that data set. What we've called response rate here is a data element in LityxIQ is associated with the response rate variable from our data set. Okay. What that means is when I run this and execute these scenarios, it will pull data in from that data set, and the nice thing about that is as that data set changes, it's updated over time, I get fresh new sales data or fresh new forecasts in, my optimization results will reflect that. Now let's jump into the scenario itself. So I've labeled this scenario optimizing response rate. So let me go in and take a look at how things are structured here. Very simple to set up. Again, there's no mathematics or programming involved here. And first thing we do is define what is our business objective. Okay, so as we mentioned before, our first little step here is we're going to maximize overall response rate. Notice it's completely user-defined. All those summary metrics that we just defined and built in the metadata are available to me here as objective functions. Okay, so I just happen to be picking one of those, and if I define and add other objective functions to my problem later on, I'll have those available to me here to optimize against. The additional data rules is an area where we don't have any defined in this particular problem, but just a quick note that we can amend or override any data that's coming in from that data set we pointed to here with additional data rules. So for example, we can add maybe a seasonality multiplier to our data that says in month 2 we usually have a seasonal spike, and so our response rates tend to go up by 20%. So very simple to add and augment to the data coming in from our raw data set if we need to. But I do want to focus more on the constraints tab here. And again, what is usually a very complex set of mathematical code to define the constraints of an optimization problem. Here in LityxIQ, we're making it very business user focused. So I can add any number of constraints based on any number of these summary metrics that we've defined. Okay, I have defined constraints that go along with the 5 that we mentioned in the PowerPoint. So let me walk you through those and show you the ease of kind of coding those up, although coding is the wrong word, but defining those here in LityxIQ. So the one constraint we labeled limit total number of calls. If we go in and see how that's defined, it's based on the metric total calls that we've defined. And we've defined it simply as the total calls being less than or equal to 5,000. That was how we wanted to define the constraint when we walked through the PowerPoint. And that constraint applies to all combinations of all levels of all 3 of these dimensions. Okay, so it's really a constraint that has to do with the total number of calls across the entire business problem. All right, very easy to define. Check some boxes and enter some numbers. How about the second one, the minimum number of calls for each sales rep? Let's go ahead and look at how that one's defined. So again, this one is also based on the metric total calls. In this case, I want the total calls to be greater than or equal to 50, but in this case, I want the this constraint to not be based on the dimensions themselves, but on this attribute that we called sales rep. And I want to define it so that without checking the combined box here, so that this constraint will apply separately to each of the sales reps that I've selected, which in this case is all 3 of them. Okay, so this constraint will then apply to Jane, separately to Joe, and separately to Josh. So it's really a way to define 3 constraints all at once with a click of a button. The third constraint was our desire to focus on segment 1 as a percentage. And so again, our underlying metric here was total calls. But instead of the constraint having to do with the straight number of total calls, we want it to do with the percentage of total calls. Okay, so I want the percentage of total calls to be greater than or equal to 65, and I believe it was labeled as 55 in the PowerPoint, so a mistyping here, but greater than or equal to 65. And in this case, I want the constraint to apply and work for all combinations and combine across all levels of periods and products, but I want it to apply only to one of the segments, and of course that's segment 1. Okay, so this constraint will apply to segment 1 combined over all products and all periods. The fourth one was we wanted to force a minimum number of total sales just to ensure that we're getting some value out of our result as well. The one difference really here with this definition is that it's now based on a different metric. Okay, so any of the metrics that we've defined, I can set up constraints to be based on those. So here my metric is total sales, and I'm saying I want the total sales to be greater than or equal to 1,000. And again, like that first constraint, this constraint is an overall constraint, so it applies combined to all levels of all 3 of our dimensions. And finally, that fifth constraint, where we wanted to ensure there was a distribution of effort over the months. Again, we're defining effort here as the total number of calls made, so we'll base the constraint here on that metric. It's, again, a percentage-based constraint, so we're saying we want the percentage of total calls to be at least 45%. But changing things up a little bit here and saying that we want it to apply to combined across all levels of the products and segments dimension, but separately for each of the levels, all the levels within the periods dimension. So I don't have that combined box checked. So separately for each. So again, it's like that second constraint. It's really defining 2 constraints in one here because there are 2 periods, and this constraint will apply separately to each of those. Okay, so it's really as simple as that to set up and define constraints. And we now have a problem that's ready to go. So I'm going to come back here and run this scenario, execute it in real time. And as that's running, by the way, this is a very straightforward and simple problem, and it's not a difficult in terms of the mathematical solution. But it will run, and we'll see its progress here in the console window. As it's running, I'll also mention that we can schedule scenarios to run either on a date and time based schedule, or we can set it up to run automatically anytime the underlying data behind that scenario changes. So it makes it very easy to automatically refresh our optimization runs if our data changes. So the run is complete. We did get a warning here, and all this is saying is that some of the data elements that we described did not have any data provided, and that refers back to that total number of customers universe size data element that was automatically a part of our metadata. And remember, I mentioned at that time that we just set it up to have 1,000 used as the default value. So this is just letting us know that it used the default value in all cases for that one. Okay, but the scenario is run. Let me drag this out of the way. And we can now go ahead and take a look at some of the results. So I'm going to go into scenario analysis and hit summary. And we can, again, have access to all of the metrics that we defined. We have access to them here in terms of the analysis and summary results. So, for example, if I want to go ahead and get an overall view of the results, I'll go ahead and check all those metrics and ask for a chart, an overall summary chart. And this is, in fact, the chart that was part of the PowerPoint. So we can see, for example, our overall response rate we'd expect from this optimal allocation is 6.16%. Overall sales per call, $4.61, and so on. This information can be exported as a graphic and put into a PowerPoint, as happened here today, given to your managers or to your clients as well. Information can also be extracted in tabular format, and if I want, I can drill down into the dimensions themselves. So if, for example, I want to see what I'd expect looking at things from a sales rep perspective, I can see that the way things are distributed across my 3 sales rep, for example, in terms of total sales, is I expect Joe to generate a little over $6,000 of those $8,000 in sales. I expect a little over $1,000 from Jane and a little less than $1,000 from Josh. So I can also break down my summaries by dimensions and their levels. So interesting thing here is we've just looked at one problem, right? Response rate, optimizing response rate, one business problem. Or really, I should say one business objective. But what if we take a look at those results and ask, what if we wanted to optimize against total sales instead? How would that change things? So what we can do real quick here, and again, part of this playing with different scenarios and playing these what-if games in LityxIQ is, let me go ahead and make a copy of this scenario and maybe relabel it optimize total sales. And so that process made a complete copy of the settings behind that scenario. And all I'm going to do is come in here, and instead of using the maximize overall response rate objective, I'm going to switch that over to total sales. And also in the constraints tab, because it's not really important to us anymore, if I'm maximizing total sales, I'm going to come to this 4th constraint that forced a minimum total sales, and show that we can deactivate a constraint at any time without deleting it, so that another way to sort of play some what-if games and see what the effect of using or not using different constraints is. And so now we might, now that we've defined the second scenario very quickly, go ahead and run that one, clear out our console. And what LityxIQ will be now doing in the background is running the second scenario, and our goal will be to compare these 2 scenarios. What kind of different results do they come up with? And what is interesting, and we'll see here in a second, is that optimizing response rate and optimizing total sales may seem at their outset to be kind of similar objectives with each other, but they may not be. They may lead to very different results. So this allows me to go in, and now that we have a couple scenarios, click on the Compare Scenarios analysis. We'll choose both of our scenarios here. And let's go ahead and just quickly look at a couple of overall summaries. So for example, let's look at my overall summary for our response rate metric comparing these 2 scenarios. So not surprisingly, because that first scenario was set up to give us the maximum response rate, that response rate is higher. It's at 6.16%, as we've seen. The response rate we'd expect to get if our goal is now optimizing total sales is actually less, about 1/3 less, in fact, about 4.2%. But, of course, where we've traded off response rate, the gain will be on the total sales side. And you can see the big effect here. So, in fact, optimizing response rate and optimizing total sales lead to very different ways of assigning this effort and the calls that we make out to these different levels of our dimensions. Optimizing total sales, we expect over 20,000 in sales versus the 8,000 or so that we expected from our plan based on optimizing response rate. So very different results if I have different business objectives. Of course, there's no single answer, because what you're trading off with one, you gain in the other. And finally, the end goal, of course, is also to implement that plan. And so as we had shown in the PowerPoint, we can get to, through this detailed summary output, what is that overall plan. So here I've asked for the detailed calls to make results for our optimizing total sales scenario. And you can see those optimal calls to make look different in this case than they did, as we saw in the PowerPoint table, for the optimized response rate plan. Okay, so this can be exported, pushed into another system like our internal CRM or automated marketing systems. Okay, so let me use that to jump into a second example. And that being a toy problem, I want to jump into a real problem in the retail space. Again, based on some real data. This is a high-tech retailer. And let me set the problem up again quickly in this case, going through the metadata since we now have an understanding of how this works. Our problem here is that we want to optimize the number of contacts we make across different marketing dimensions. So contacts in terms of a, think of it as a direct mail contact plan. The dimensions that we've defined for this problem are 5. We have channels, 3 different channels. We have customer segments. We have periods, products, and subsegments. Notice that if you multiply out 3, 3, 6, 1, and 2, you get 108. So there'll be 108 different combinations and dimensions in their levels that will be the backbone of this problem. We've not defined any attributes, but we have defined a number of data elements here to support the optimization. I wanted to point out just a couple things in particular. One is we did not use any cost-related data in our prior example, but certainly cost is often a big piece of an optimization result. And so one data element that we've defined here is cost per piece. So for every piece that gets sent out, there's a different variable cost that we incur by sending that piece out. By the way, as a quick note, the channels that we have here are a basic catalog, a premium catalog, and a simple direct mail channel. Okay, so presumably the cost per piece would be different depending on which channel we're touching our customers through. I also have defined here a data element that is called a conditional data element, and this allows us to define fixed costs. Okay, so for example, there may be a fixed setup cost having to do with our catalogs. So even if we send, whether we send 1 catalog out or 10,000 catalogs out, we still would incur a fixed setup and design cost to create those catalogs. Okay, so LityxIQ allows us to have these conditional data elements which will handle things like fixed costs versus variable costs. Okay, otherwise we have data like we saw in that first example, response rates, revenue per responder, and expected revenue per contact as other ones. We've also defined quite a few summary metrics here, so things like the total number of people contacted, okay, similar to our total number of calls in that first example. The total costs, or in other words, the total budget we'd allocate to the solution is defined, total number of responders and revenue that we'd expect to get. As well as some complex metrics like our overall profit, just taking revenue and subtracting out costs, and ROI, profitability divided by cost, and even something like total budget, including those fixed setup costs. Okay, again, all these defined very easily through that point-and-click interface. So now, in this problem, we have defined, again, a number of scenarios, in this case 6 scenarios, and the scenarios are named based on their business objective. Okay, so we have a scenario here that's looking to maximize the number of responders and finding the best way to allocate our marketing budget and our marketing effort in order to do that. Another one is looking to maximize profit and revenue per order and ROI and cost per order. So different ways, as we saw in that first example, these different ways of focusing on different business metrics can lead to very different optimal solutions, very different ways to allocate our budget. And in fact, this 5th one here is actually somewhat interesting. If you notice, it's called minimize budget. And if you take that as it is, minimizing budget seems like a very simplistic thing to do, right? If I really wanted to minimize budget, I just wouldn't do anything, right? Don't spend any money. That minimizes budget. But we've done that in an intelligent way here. So think, for example, let's say that we have a shortage of orders compared to plan, and we need to generate 2,000 responses, kind of come from up high from our bosses, that we need to generate 2,000 more responses over this period in order to meet plan. So what I'm saying here is, let's do that. Let's guarantee, let's constrain the solution to ensure we get 2,000 responses in a way that is as efficient as possible, spend as little money as possible. Okay, so we can set up lots of different scenarios or what-if games with different objectives, constraints, and of course different outcomes. So key thing here is we may go in and look at results as we did with that first example and maybe compare scenarios. And like we saw before, what will be interesting if I want to compare these 6 scenarios to each other and look at something like total responders is I can get very different results. So of course, again, the scenario that was meant to maximize the number of responders is the one that generates for us the most responders, in this case almost 3,000. And what's interesting again though is that the other scenarios in some cases are somewhat similar, but in other cases like the one in green here, maximize revenue per order, are very different. Maximizing revenue per order is very suboptimal in terms of maximizing total number of responders, but from its own metric, revenue per order, it does a great job. Again, we can drill down into the dimensions themselves, and let's look at how these optimal solutions allocate budget across the different periods. There were 6 periods, different months, July through December, defined as a part of this allocation. And what's interesting is that all 6 of these scenarios put most of the allocation, most of the effort into August, maybe because of back to school kind of time frame, the seasonality and lift we might get there. But they all seem to spread out the allocation of budget somewhat across all 6 months. And that's because one of the constraints that's defined in all these scenarios is the desire, like we did in that first problem, to spread out our budget somewhat evenly across the 6 months to ensure that our people are busy and our FTEs have something to do across this 6-month period. So again, another interesting what-if game we might want to play here is what would happen if we remove that constraint? If we didn't restrict ourselves to allocating budget across all these months. So let's go ahead and do something like we did in that first example. Let's go ahead and make a copy of the scenario and call it maximize responders, remove month restriction. And I'm going to edit the settings for this new one. I'm going to continue to maximize responders, but now show you this constraint that was playing a role there, min spending per month, where we ensured that the percentage of total costs was at least 10% in each of the 6 periods. Let me go ahead and deactivate that. Run that one. And given that we're pushing close to the end of our webinar hour here, while that's running, I'm going to switch over to the last slide in the PowerPoint and just kind of walk through some additional functionality and technical points that you should be aware of. Some of these I've already mentioned. So the automatic universe size data element is there to automatically handle upper bounds for the optimal values. And the metadata also allows us to do things like make binary decisions. For example, at the customer level, target or don't target someone, and we can simply make that happen by setting that segment size data element to 1. In other words, the maximum value the solution will give to each level of my set of dimensions is either a 0 or a 1. So turn it on or turn it off. So we can handle binary decisions that way. And continuous values are handled as well. So for example, price optimization, just by unchecking the integer values setting in the metadata area. I've already mentioned conditional data elements allow for fixed cost data to be included. Additional constraints can be defined a little bit over and above what we've described here in the webinar. So for example, we can restrict the number of unique levels that will have positive optimal values. We can have constraints like 0 or greater than constraints. and we can have constraint bounds that come from data sets. So, for example, we've defined some constraints today that are based on hard-coded numbers like $1,000 or $5,000, but we can import those numbers from data sets as well so that they might be variable for the different levels, the different dimensions. And I also have already mentioned that there's a full integration with LityxIQ so that part of the input into the optimization process can be scores and forecasts coming from our predictive modeling solution and driving directly into our optimization solution. So in the meantime, our new scenario has finished, and a quick comparison here of just these first two scenarios. Go ahead and get rid of the other ones. And let's just look at that total responders metric. Shows that if we turn off that restriction on the months, we can generate, it looks like a little over 100 additional responders. And if I view that by period and look at our total cost or budgeting metric, what we're seeing is that this new scenario shifts a lot of the effort into the August time period, but not everything. It looks like the shifting of July, September, October, November effort goes partially into August, partially into December, with a little bit staying in July as well. So I get a better result that way in terms of number of responders, total number of responders I'd expect. But again, the key thing here is the business constraints. The trade-off is I now have unused FTEs during these other months. Very quickly, in just a couple of minutes, I want to jump you to a quick view of the metadata behind a customer-level optimization and show you how we can optimize things down to the level of the individual customer with appropriate settings. So in this case, we have a data set of individual customers or prospects, and we want to do offer optimization. What is the optimal offer to give to each of our customers? And so I'm optimizing customer contacts across different offers. In this case, my dimensions are only two. I have a hotel offer, it's my offer dimension, one of three things, and I have a customer ID, essentially. Notice there are 53,716 such levels. Okay, so I'm down now, not at business dimension levels like products and periods and channels, but down to the individual customer or prospect, 53,000 of them in this case. And as I had just alluded to, we have taken our special segment size data and given it a default value of 1 for everyone, so that for each of these 53,000 customers, they'll be either turned on or turned off to each of those channels. We either market to them through a channel, through one of the offers, or not. So a way to do detailed customer-level optimization. Again, just through my appropriate definition of metadata. So with that, I want to leave at least a few minutes